Okay, welcome to section 2-3. We're talking about rate of change in slope, a concept that should be very familiar to you from Algebra 1. We looked at it as well, the idea of slope, in terms of graphing a graph if you're given an equation. This section is really just about calculating rates of change, calculating slopes, because we're going to need that when we get into section 4, when we start talking about writing equations of lines if we're given slope or if we're not given slope, and we're given some other information about the line. Okay? So, first thing your book talks about is this idea of a rate of change. Okay, and here's the definition. So if you want to take a second to pause the tape and pause the video and copy this down, here it is. So rate of change, this concept of change is really fundamental in math. I mean, algebra is about change. Calculus, when you get into that, that's really all you're studying is change. So this is a very light, cursory look at that idea. So rate of change is just how much one quantity changes in comparison to how much the other quantity changes. Okay? And there's a couple different ways we can define that. So in words, we can say it's change in y over change in x. This is the form of the equation that I like the most because it's the most mathematical. Notice these little triangles. These are Greek letters. In case you've never seen them before, it is the Greek letter delta. And delta always means change. I think in chemistry, for those of you that are in chemistry this year, you're going to talk about delta when you're talking about changes in quantities when dealing with matter. So get used to that. When you see that Greek letter in a formula, you're usually talking about a change. Okay? Let's calculate some rates of change. So one way we can calculate it is in a word problem. So, a problem after my own heart. In 2011, 7,401 students applied to St. Joseph's University. In 2006, 6,500 students applied. Find the rate of change from 2006 to 2011. Okay, so if we're doing a rate of change, I'm going to just abbreviate that as ROC. From 2006 to 2011, we're going to start with the change in the Y, which would be the change in students, over the change in the time, which is the years. So, and you're going to see this looks kind of familiar, the calculation here. For some reason, your book calls it rate of change first, but it's going to look like a slope equation if you've seen that before, which I know most of you have. So we'll start with 7,401 because that's how many applied in 2011. We'll subtract 6,500 from that. And then we'll line up the 2011 underneath the 7,401. And we'll line up the 2006 under the 6,500. And then we'll subtract separately. So I know that one's 5. And the other one, I want to check with my calculator so I don't give you the wrong number. Minus 6,500. 901. Okay, and then we can divide that by 5. We're going to get a decimal. 180.2. Now, note about units. The units here, it is a rate. So like rates, when you think of speed, miles per hour, it's going to be the same idea. But instead of it being something like that, it's going to be whatever the unit is the y per whatever the unit is in the x. I'm going to write that down here kind of on the side as far as the units go. It's going to be y per x. So in this case, it is 180.2 students per year. That 180 more students each year are applying to St. Joseph. We assume that that rate of change is a constant. All right, here's a table of values. So we want to see the rate of change for the table. Same idea. So we're just going to pick any 2 points we want. Maybe I'll use 2,8 and 1248, and we'll do the same thing. So we'll use our delta y, delta x. We're going to make time be our x, distance be our y. So we'll do 48 minus 8 over 12 minus 2. It's 40 over 10, or 4 feet per minute. Again, units in y per units in x, feet per minute. Okay? You could have picked any pair of points you wanted. Graph, same idea. Okay, so this is a graph of the percentage of computers in U.S. households from the year 2000 to the year 2004. So same idea. We'll do 74 minus 61, our y, which is percentage. Our x is years. So we'll do 2004 minus 2000. That is 13 over 4, which is 3.25% per year. So we can say, based on the data, that the percentage of computers in U.S. households increased by about 3.25% every year since 2000. Okay? This all leads us then to the idea of slope. We've been calculating slopes, like I said before. We just haven't looked at them in terms of a graph of a line, right? But that's what slope is. It's the rate of change of a graph. And here's your formula. Should look familiar to you. Copy it down. y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are 2 points on a line. Okay? Remember, it doesn't matter which points you pick for these, but you have to be consistent when you line them up into the formula. And I'm going to do a couple examples momentarily that will remind you of that fact. And then it should be like getting back on a bike. Okay? So here's a couple examples. So we'll look at the first one. The slope of the line passing through the points -1, 4 and 1, -2. So I'm going to label the first one just to get us back into it. Sorry, but the x's are looking like y's. That's my pen. x1 is -1, y1 is 4. x2 is +1, y2 is -2. And then it's just as simple as plugging into your formula. y2 minus y1, x2 minus x1. y2 is -2, y1 is 4. x2 is 1, y1 or x1 is -1. Now we just subtract the top, that's -6. We combine the bottom, plus, that's 2. So my slope is -3. So if you think of this idea of a rate of change, basically what this slope is saying is rise over run, like we talked about with the graph. For every change 1 unit on the x-coordinate, or excuse me, on the x-axis, the graph is changing -3 units on the y-axis, down 3 over 1. Okay, let's look at another example. All right, so again, to tell you, it doesn't matter which one you do first and second. I'm going to make 24, 9 be my x1, y1, and I'm going to make -8, 11 my x2, y2. So we'll do y2 minus y1 over x2 minus x1. We subtract. 11 minus 9 is 2. -8 minus 24 is -32. -1 over 16. That's my slope. So for every 16 units we move in the positive x direction, we're going to move 1 down in the y direction, okay? Now what if I gave you a graph? Easy. Just pick 2 coordinates and use your formula. So I already gave the 2 points here, so let's just pull out the coordinates. This is 1, 1. This is -1, 0. So m equals 1 minus 0 over 1 minus -1. And again, I picked y2, y1, x2, x1. The top becomes 1. The bottom becomes 2. My slope is 1/2. Okay? It's just that simple. You have some practice problems in your note sheet. Go ahead and give that a try. And with that, I wish you a good evening. Once we get slope down, then we can start talking again about writing equations of lines. Either we know the slope or we know 2 points. But that's going to be our next challenge. Okay? Have a great